buddies, and welcome back to this masterclass for the beginners. And once again, is one and only the Wolf. And guys, today I'm really excited to make this video for you buddies because I'm here for you. So guys, in the previous lessons we talked about variables and we talked a little bit of data types. So still we are going to talk of data types and also talk about characters, numbers, decimal precision, memory size, and we finish off by real life examples. So still that is along data types. So welcome and let's get started. Remember, once again, he's your guy, the Wolf. Welcome once again. So we start off by defining what character data types. So okay, let's get started by creating a project. So I'm using a count block here, and I want to create a new project by creating this. Cancel this and come to the file here. I create a new project, and then I pick a console application, and then I click this go, and here I'm just going to click next, and I pick C, and then I click next, and I give the project name, and I say data types. This is going to call it data types. Today we start with my characters. So let's finish by clicking next, and yes, finish. So here we have our project and the source, and we have the main here on here. So let's define what is character type of data. So the char data type is used to store a single character, because a character actually stands for like A, B, C, D, so we can store one character like A or B or C. So this character type, it normally stores one character. So the character must be also be surrounded by a single quote, like for example A in a single quote, or C with a single quote, and we use the division C format specifier to print it. So without much ado or much talk, let's do it. So first of all, we're going to start small. We always small, so we don't go big. We start from small. So I'm just going to start off by declaring a variable here, and this and around here, and create a character. Data. So card, and I say my grade, just like that. My grade. Oh, this is grade. This grade. And normally, I know you guys you normally get high grades, so I'm just going to give you an A, and just put a single quote there, and put in some A, right? And finish on by this there, this semicolon, and then we're going to print and say, because this is a character, we say that a character type of data occurs in one character, and the character can be A, B, C, just one of them. So you're going to specify in here and say that you must use the this modifier, and to print out you put this down here and specify what is a character type to print and see there, and then now you put a comma there and then put your grade here now. this is called the format specifier. We use it normally. We've been using it. So return 0. So let's run this and see what we have. So now just to build and run. Oh, it's running. Yeah, there it's running. So you can see that we have our A here. So what is that? So we have used the character type, which carries or stores only one character, single character in a quotation mark, and we have printed out. So that is it. So let's talk about this next thing. Hold on a little bit. So alternatively, if you are familiar with ASCII, have you ever heard of ASCII? So you can use ASCII value to display certain characters. Now that these values are not surrounded by what? They're not surrounded by quotes. So as they are numbers, for example, if this was a number, you cannot surround it with quotes. But if you understand or you have ever heard of ASCII, you can display using this. So ASCII is so easy, ASCII is just numbers to represent a letter, and it's simple as that. So let me just try it and see what we can understand a little bit of ASCII to print this out without using these error codes. So still we have our, let's change a little bit things here and have this character A. So I'm having a character, so A, and I say 65. Actually number 65 is actually, if you go to the ASCII code, you'll find out that 65 is just A. So if a computer notices this, for example, if you use that ASCII code, the computer normally knows the number 65 represents A. So those are ASCIIs. So again, I want to put B, which is 66, and the C, which is 67. 6 equal to, let me see, 67. So from here, I just want to print out and see what we have here. So let's print A here, and again copy this. See here, and let's run it and see what we have. So you see here we have the small letters. Let's see whether we can have capital letters, because this now is specifying that it's a character. If we wanted to print this variable, then we change this to an int, probably we can get, and again change this as an int. So you see it's a very different thing from what we normally do. So here is just, these are just as keys, and I've already told you that. So let's run this and see what we have. So build it and run. So as you can see guys, actually I should have included new line here. So I should put this in a new line backslash, so remember to include this character to print in a new line. And we should have put this in a new line. So let's compile this and run. So as you can see guys, we have A, B, C. So these are ASCII code, and we did not use single quote over there. So that is it. So let me give you some tips. Remember, a list of all ASCII values can be found in ASCII table references. You can go to online and just get all the ASCII references where, let's say, for example, we have a few numbers, like let's say 0 to 31. These are just control characters. You can just check out. And let's say number 32 is just the space. Number 3 is just the exclamation mark. And number 34 is just a quotation mark. Number 35 is just an hash. And 36 is a dollar sign. A percentage sign is just number 37. So guys, I don't want to do this because you can actually go there and see how these are key. For example, number 1 is actually number 0 is 48, and number 1 is 49, number 2 is 50. So these are ASCII codes, so you can go and find it out. So let's talk about numbers. So what about numbers? So in C, numeric data types are also data types. So numeric types, we use an int when you need to store a whole number without decimal. Like for example, number 35 or 1000, and let's say a float or a double when you need a floating point number with decimals, like let's say 9.9. Let's say 3.145. So those are number doubles or floats. So let's do it and see the int type here. So we have already said that int stores a full number. Yes, so an int actually store a whole number, not a full number, but a whole number without a decimal point. So let's do it. I want to delete all this, leave the last one here, and write it, and I assign it, let's say 1000. This is a whole number, right? It's not a decimal number. And then if I print out, I should put, remember we said we can put I here, which means an integer. Or you can put this B, still means a double number, but it still means an integer number, a whole number. So just paste it in. First of all, let's run this and see where we are right here. An error expected. Oh, I did not sign here. So as you can see, we have 1000 there. This is an integer, whole number, and again you can just change this and put there, still it works. Okay, and again we have 1000 there. So let's talk about a float number. So a float number you have to declare like this. You need to check this integer because a float number is a number with a decimal point. So just declare just like that. Is over here. Float, and I can say a float number, and I can put a float number here. Let's say 32 point out, say 7.99. And now this I will have to check this to F, meaning a float number. This are formatting. This I will format this now. Format specifiers. So run it again. So we have a float number of 7.99000. So guys, let's talk again about a double number. So what is this double number? So a double number, a float number actually has got this only one value here and some decimal points. And about a double number, which is used to double. Remember that number has about, let's call it 8 bytes, and a float has 4 bytes, and integer also has 1 byte to 4 bytes, and what else? Yeah. So let's do this. Change this to, let's say, 20.99. Let's spread it out. Oh, then I need to change this to double precision, which is L and F. Yes, double precision. So this one here, compile it. So we have 20.999. 20.99000. So one thing that you have to notice is that a float. Let's talk about a float versus a double number. So the precision of a floating point value indicates how many digits the value can have after the decimal point. So you get that the precision of a floating point number indicate how many digits the value can have after the decimal point. So the precision of a float is at 6 or 7 decimal digits, while the double variables have a precision of about 15 digits. So therefore it's often safer to use a double for most calculation, but not that it takes up twice as much memory as a float. So a float is like 8 bytes versus 4 bytes. So that's the difference. So the difference is the double number takes a double precision of decimal, like 15 decimal points, and the float only takes like 6 to 7 decimal digits. So you see, the double number can take a long storage, and the other one is half of it. Let's talk about scientific number. So a floating point number can also be a scientific number with an e, which means exponential, to indicate the power of 10. And here the e indicates the power of 10. So how do we do that? So let's build a scientific number here. I'm going to create this plot. Let's say let's create a variable called f1, right? And then give a scientific number which has got an e, which indicates the power of 10. So let's say 35 power 10. 35. Let's pick a small number. Oh, let's try this first of all. 34 power what? 3. This should be a very huge number. And that's why let me create another one here. Double. And this is T1. I just want to give it again a scientific number, which is 12. Let's say 12 power 4. So I want to print them all. The first one, this one, this is and one F1, and then again this, and also this, and change these to double precision. D1. So let's print it out. Error print before. I'm an error expect. What went wrong here? Something is expected. Okay, yeah. Actually, just printing the new line. So you can see we have 34,000, we have 12,000. So what is this? What is that? So a number powered with this E here, it has given around this number here, 4,000. The one is 120,000. So this is just the power. So if you take 12 power 4, 34 power 3, that should be even, it's cool. So those are the results that we got. So let's again talk about the decimal precision. So once of all, let's set decimal precision. So you have probably already noticed that if you print a floating number, the output will show many digits after the decimal point. So you can see the fourth number, we have this here. You see this one. So as you can see, it has already so many decimal output around here after the decimal point. So you can see all this. So let's do it. Let's do some thing. I just want to delete all this and create a float here. Because now we want to talk about these set decimal precisions. So okay, let's do it first before we talk. So float my float number. Let's say that's my float number is equal to, let's say, 3.5. And again I create another one and again I call it one. Number is equal to, let's say, 18. Right? So that's what I'm printing out. So print I don't forget this. Yeah. So print function. And format specifier I'm going to use always these percentage F and then new line. I want you to line and press it, comma here, put in my value which is my fn, and again so remember this one we actually output, so output 3.5 and then so many zeros, like 4 of them. And go again this. This down here. Now this one is in non-float, double precision, double float number. So what did I do here? So copy this. So this one will output again 99 with another 4 zeros. So if we want to first of all, let's run this. See, so you can see we have so many zeros here. So if we want to remove these extra zeros, this is decimal precision. These are decimal precisions, right? So you can use a dot and then followed by a number that specifies how many digits that should be shown after the decimal point. So to do that is so simple. You just again let's use this what we have here. Count this, and we have a float here, and we have our number here. So this guy repeat. So I just want to print. Let me just remove this. And now I just want to do very simple stuff here. So I'm using just this space. So I have this float number here in the line, of course, and I have my float number. So this is just the default, which will show 6 digits after the decimal. So this will show the 6 digits. Let me just actually comment here and say that is default show decimal point. Are you going so far? Oh, it's point. Just like this. So this will show by default will show 6 decimal point because this will be that is a 6 decimal point because it's a float number. And again, let's see the one that will only show 1 digit and also show 2 digits and only show 4 digits. So again, I'm just going to copy this print function. Now this one, I just want to say, you see, now here I did not include anything, but if I want to show how many decimal I want to see after the decimal point, I just put the number here. So in this, before this F here, that's where I'll put 1. And if I put 1 there, then this one will only show 1 digit. So again, just copy this and paste it down here. And now this one, I just want to change this to 2. And as you can guess, this will show 2 digit. And again, this down here. And, guess what? This will show. Let's just put 4 so that it can show only 4 digit. So let's run this and see what we have. I'm going to here and run. So, what did you do? We did not show the right thing. No, there's a problem somewhere. Let me check it out. Okay, let me check it out first. Okay, I think, where's my code? I think I forgot to put a point here. I just said that, remember I just said that we use a dot followed by a number that specify how many digits that should be shown after the decimal point. So we need to put this dot here and also here. Down here, and finally down here. So we must include that dot. So again, let's run. Yeah, it's working. So it only showed 1 decimal, 2 decimal, and 4 decimal after the decimal point. So and that is it. And now let's talk about memory size. So we want to find the size of an operator. Let's see. So to get the memory size, we introduce in a data type chapter of lesson that the memory size of a variable varies depending on the type. So you see, simple. I mean, the memory size just depends on the data type that we put in that variable, right? So for example, we have a data type which is an int. So I already told you that an int, the size of an int is 2 to 4 bytes. A float is 4 bytes. A double is an 8 byte, and a char is 1 byte. So the memory size refers to how much space a type occupies in a computer memory. I don't know how I can explain that. So actually, to get a size in byte of a data type or a variable, we use the size of operator. So that's what I meant about size of operator. So we use that keyword, the size of operator. So let's do it. So I'm just going to delete all this. I'm just delete all this. Okay, so remove all this, everything, and then I just want to create an int y int, and just initializing, and a float, and I call it my float, and then I have a double, and I call it double, and then we have car means a car, just like that. So I just want to print this and use the method or a function called the size of to find out what size do these variables have. So how do we do that? It's so simple. We just print function. Remember to use for specifiers. So this should be a percentage. Okay. Here we will use LU. And then the new line. Let's just leave this means LU. And just use that size of size of this variable here. Which variable? This one. My int. Copy. Paste it here. And again, I'm just going to copy this. And paste down. So I'm going to put in this my float. Actually, we use this LU when we don't know the symbol. When we don't know the size, we just use this. So this. Paste it here. Copy this. So we want to know these data types. What size do they have? Because we have this basic form. Let's find out the size. So I'm just going to run this. There we go. So we have noticed that an int type has got 4 bytes, and also a float has got 4, and then double has got 8, and our current has got 1 byte. So that is all. So what you need to notice is that we use the %lu format specifier to print the result instead of percent being for an int. Yeah, it is because the compiler expects the size of operator to return a long unsigned int. So L means long unsigned int. So always the compiler will expect a long unsigned int instead of int, or int which is %d, or some computer it might work with %d, but it's safer to use a long unsigned int. So LU means long unsigned int because that's what it expects. Okay, so why should I know the size of it? So knowing the size of different data types is important because it says something about memory, so usage and performance. So for example, the size of a character type is 1 byte, which means if you have an array of, let's say, 1,000 character values, it will occupy 1,000 bytes. So total bytes is 1 KB of memory, right? So using the right data type for the right purpose will save memory and improve the performance of your program. So it's safe to know the size of your data type. So we will learn this more about the size of operator data in these classes in this course. So and how to use it in different scenarios. So that is it for this, and let's talk about different things. So let's talk about a really live example where we can use this data in C. So real live example. So here real life example of using the different data type to calculate and output the total cost of a number of item. Where are we talking about here? It's here on our desk, anyway. Let's do it. So let's create a variable of different data types, and just want to move on this, and let's create a variable of different data types. So I'm just going to start with int, and I call it item. Oh, what did you do, bro? Items, and we have like 40 items, right? Create another one, which is a float. This is the 40 cost per item. Let's say if you come from this other country where the car is giving us some problems. And I'm just whispering. So float, and cost. Total cost will be equal to items. We have the cost per item is this, and we have 4 items. We just multiply these two numbers to get the total cost. So it's items multiplied and this is standard cost of items, right? It's like this. That is the way we get the total cost. So let's say let's have a character. So we are using data types to do something here, right? So this is the real time thing now. Currency is equal to single quote. We use gauge. So that is the currency we use around here. And then let's now print the variables. You can even say seems I ate some poison the other day, but I will not die. I'm not going to die. Different. It's not different. Oh, just leave it. Leave it. Just wasting time. So, let's print out. See what we have. So print this print and say, what are we going to say? What do we want the program to say? Because now we're going to say it now. Let's say the number. Just say number of pages, say number of items should be format specified. This one here is an integer and put things in that order, just like that, and put a comma here. And now we items. So again, let's copy this here. This thing here. Let's say the cost per item. Let's say this now is we should use what we say a dot and to decimal more for float, and we do it in a new line. We can say the cost per item in this. The cost per item is called and again lastly let's check the total. Copy this and say total cost. You can say cost and say it's equal to give it a value in there. Is equal to percentage, again true float in the new line, and let's say total cost. Copy this and I paste it. So this is a real life way where we can use this. So let's run it again and see whether we run it right. It's running. Yeah, the number of items were 40, the total cost per item was this, and the cost per item was 8.8, and now the total cost is 350 now. We did not include our currency. Well, we should use the currency actually, the current. So just add our currency here. Do we really need to do that? Yeah, you should do that. So we do that to put your currency thing. should include the character. So our character Kenyan shillings. Let's do it. Let's include it. So let's include our currency here. So the currency should be copy that. Okay, put it here. Put a comma, then paste it. Put a comma here. And paste our currency there. Yeah, when it works. And we have oh, what? Oh, I didn't total cost. Total cost per item, and then currency. What did I do wrong? Let me check it out. Without wasting time. Wow. I think I'm dumb. Yes. I should have specified these because these are character and I only have the float here, float and double, so I'm not specified format specified for the character. So to do that, I just have to come in here, and this before the new line, I should add the specified, say the percentage character because it's followed by a float value. And then a character. So again, copy this. This is the problem. And paste that there. Now we have actually something. So here we go. Ooh, I have H. Only H. Why do I have only H? Oh. Because a character is only one. What should I do? Do I have strings? No, maybe for now because a character only means one character. So let me just have dollar sign for simplicity. Because it means that we need a variable that can take, or we can use an array. Okay, for now let's use a dollar sign to print this one. We need only one there. So run this. There we go. We have a dollar sign there. So that is it for today's class, and guys, thank you so much for joining this class of today. Thank you, and see you in the next class where we will talk about type conversions. Let me see whether type conversion we can do it right here. But let's say goodbye and see you in the next class. Goodbye.